In this video, we're going to talk about divisibility rules. You might say, Ms. Cooper, you should have taught us this before when we were doing division. This is something I'm hoping that will help continue to advance your understanding of division and make you even faster and more confident so that when you continue with division, this will help you. So a number is divisible if it can be divided evenly with no remainder. So for example, 18 divided by 6 equals 3. If we did 15 divided by 6, we could only say it's 2 with a remainder of 3. We want no remainder. So there's some rules about how we can know if a number will go in evenly without actually having to do the division. Some of them are really good. Some of them are not so good. The 7 and 8 one we'll leave till the end, but the one for 2 to 6 and 9 to 10, you might already know this and not have actually thought about it concretely, but just be familiar. For example, I'm sure many of you are aware that if a number ends in 0, 10, 20, 30, 40, all the way up to 1,000,000, 1,000,000,000, whatever, as long as it ends in a 0, it's divisible by 10. Without even having to do the division, I can tell you 10 will go into it evenly. You can take groups of 10 out and not have any left over. So the example I've done here, 130. It ends in a 0, so I know, yes, it is divisible by 10. Check. And my answer is 13. Okay, another one you might be familiar with is, we'll look at the 2. We know a number is divisible by 2 if it's even. 2, 4, 6, 8, 10, 12, 14, 16, 18, on and on and on. So I've just randomly put 32 here as my example. Obviously, that's an even number. Anything that ends in a 0, 2, 4, 6, 8, or 0 again is divisible by 2. This doesn't tell you what the answer is. I know 32 divided by 2 is 16. 16 plus 32, or sorry, 16 plus 16 is 32. But yes, that works. For, let's see, what's the next one you might be familiar with is the 5s. If the last digit is a 5 or a 0, we know it's divisible by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I don't know what the answer to this one is. So I've written 17,895 divided by 5. All I know is without having to look at my calculator or do the math, yes, it ends in a 5 or a 0, so it is divisible by 5. I'm just going to quickly look at my calculator to do this answer for you. But the more important piece here is yes, it is. So yes, it is, and the answer is 3,579. So 5 times that number equals that. Okay, let's go to, we've looked at the 2s, the 5s, and the 10s. Those are the ones you're probably already familiar with. So let's jump now to the 3s. We know a number is divisible by 3 if the sum of the digits is divisible by 3. So remember, the sum is the answer to an adding problem. So if we add up the digits and that sum is divisible by 3, then we're good. So the digits we have here are 2 and 4. 2 plus 4 equals 6. So I'm just going to write a little 6 there. 2 plus 4, I've added those two digits together. And I think we all know 6 can be divided by 3. Obviously, 6 divided by 3 is 2. So we automatically know, yes, it is divisible. Doesn't, again, tell us the answer. I'm hoping you know 24 divided by 3 is 8. But yes, it is divisible. Once you know the 2 rule and the 3 rule, you can automatically do the 6. 6. The number is divisible by both 2 and 3. Sorry, the number is divisible by 6 if it works for 2 and 3. So remember our rule for 2 is it's even. Yes, the last digit in 78 is even, so that works. Is it divisible by 3? We said in order to know if it's divisible by 3, we have find the sum of the digits. So 7 plus 8 is 15. And yes, 15 is divisible by 3. I know that 3 times 5 is 15, or 15 divided by 3 is 5. So we automatically know, yes, 78 is divisible by 6 because it is divisible by 2 and 3. Again, it doesn't tell me what the answer is. I'm going to look that up quickly. Divided by 6 equals 13. Okay, now let's look at the 4. So we know a number is divisible by 4 if the last 2 digits form a number that's divisible by 4. So we're only looking at these last 2 digits. So in this example, 24. I know 6 times 4 is 24. So yes, 24 is divisible by 4. Therefore, sorry, I'm saying 4 too much. Therefore, 224 must also be divisible by 4. Let's check it. 224 divided by 4 equals, yep, 56. Notice no remainders. There can't be any remainders if it is divisible. Let's go down to the 9 rule. It's divisible by 9 if the sum of all the digits is divisible by 9. So very similar to the 3 rule, but now we're talking divisible by 9. So we have 1 plus 2 is 3, plus 6 is 9. So the sum of those digits is 9. Obviously, yes, I can take 9 out of 9, so that's definitely divisible. And the answer is 14. Okay, now the only remaining rules we have are the 7 and the 8. The ones that we talked about already, I use more. These ones I do not find as helpful. Supposedly they work, but like with the 7, it says it is divisible if you can double the last digit and subtract it from the rest of the number. The number should be divisible by 7 with no remainder. That should tells me that it doesn't work all the time. But first let's look at this example where it does work. So I'm doubling the last digit. 5 plus 5 is 10. Doubled my last digit, okay. Subtract it from the rest of the number. So 24 minus 10 is 14. So 24, sorry, hard to write. Minus 10 is 14. So the number should be divisible by 7 with no remainder. Is 14 divided by 7 divisible by 7? Yes, it is. So we know that 245 is divisible by 7. 245 divided by 7 equals 35. So it does work. However, if I have a number, like I've just sort of written at the top here, 119, and I want to know if it's divisible by 7, if I use that rule, double the last digit, so 9 plus 9 is 18. 18, hard to write. And then it says, subtract it from the rest of the number. 11 minus 18, it doesn't work. Yes, 119 is divisible by 7. The answer is 17. But just because of the nature of the number, it's not big enough. You can't use that rule. So this rule does work if the number's big enough. It is not a foolproof number. I would say if it works, yes, it tells you that it is divisible by 7, but if you're not having success, don't take that as a for sure no. It's a sometimes. Notice the should. Same with this 8 one here. In our example, we're successful. It says a number is divisible by 8 if the last 3 digits form a number that is divisible by 8. So 152. The thing is, yes, 152 is divisible by 8, but I didn't know that either. 152 divided by 8 equals 19. So therefore, 6,152 is divisible by 8. But you have to know that, and I didn't. Also, what if the number isn't multiple digits long? It doesn't work all the time. These two could be helpful, but aren't my favorite rules. They will likely not pop up as much. But this gives you the overview. Hopefully we've already talked about this in class. If not, hopefully this video is helping you. We'll use them now in some example questions. So this example says, is 75,724 divisible by 3? Our rule for whether it's divisible by 3 is the sum of the digits is divisible by 3. So let's add those digits up. 7 plus 5 plus 7 plus 2 plus 4. 7 plus 5 is 12. Plus 7 is 19, plus 2 is 21, plus 4 is 25. So, is 25 divisible by 3? You could look on your multiplication table. Go down the 3 column. Is there 25? There is not. Or, I was going to say, you might have realized that 8 times 3 is 24. 9 times 3 is 27. There is no 25. So no, this number is not divisible by 3. A nice easy example here. Is 835,171 divisible by 5? Our rule for 5, it is divisible if the last digit is a 5 or a 0. That is not a 5 or a 0, so no, it is not divisible by 5. And our final example is 874,854 divisible by 9. The rule for 9 is it is divisible if the sum of all the digits is divisible by 9. Very similar to the 3. So let's see. So 8 plus 7 is 15, plus 4 is 19, plus 8 is 27, plus 5 is 32, plus 4 is 36. So is 36 divisible by 9? I'm hoping your brains are working hard and you realize that yes, 9 times 4 is 36, so it is. But you could always check, go down the 9, boom, there's 36. So yes, it is divisible, and yes, this large number must therefore also be divisible. Okay, good luck with this section.